Hi friends, myself Samir Mane, working as assistant professor in Sri Tulja Bhavani College of Engineering, Tuljapur. Today we learn on the topic Introduction to Other Renewable Energy Sources, especially we concentrate on tidal energy. The content of this video lecture is Introduction to Other Renewable Energy Sources, Energy from Tides, Tidal Energy Principle, main parts of tidal power plant, operation method of utilization of tidal energy, then advantages of tidal energy, disadvantages of tidal energy and its references. The other renewable energy sources are as tidal energy, geothermal energy, ocean thermal energy conversion, mini or micro hydroelectric plant, wave energy. Let's move to our content, tidal energy. Tidal power or tidal energy is form of hydropower that converts energy obtained from tides into useful form of power, mainly electricity. Although not yet widely used, tidal energy has the potential for future electricity generation. Tides are more predictable than wind and sun energy. Tidal energy is nothing but energy from the tides. Tide is a periodic rise and fall of water level of sea which are carried by the sun and moon on the water of the earth. At the times near full or new moon, when sun, moon and earth are in line approximately, the gravitational force of sun and moon enhance each other. Then tidal range is large. That is, the high tides are higher and low tides are lower than average height. These high tides known as the spring tides at full moon condition and near the first and third quarter of the moon tides are known as neap tides. This range is not constant. It varies during the 29.5-day lunar month. The mean tidal range varies from place to place also due to the interaction of sea with the local coastal line. Let's see, the coastal line place deals with average tide in meter. In Gulf of Kutch plus in India, its average height is 7 to 8 meter. In Kerala or down to Kerala, just only 1 meter average height. Then in Bay of Fundy, placed in Canada, there is having 20 meter of average tide height, which is highest in the world. Tidal energy principle. During the high tide, water flow into the dam and during the low tide, water flow out which results in moving the turbine. Then although not yet widely used, tidal power has potential for future electricity generation. Tides are more predictable than wind energy and solar power energy. What happens in this? When sea is at high tide condition, the tide R moves towards the tidal basin from the dam. In the dam, there is a turbine. Due to the motion of the tide, turbine is get rotated and we get energy. Vice versa, at low tide condition, the water from the tidal basin moves towards the sea and this turbine is get rotated. This tidal electricity generation works as tide comes in and again when it goes out. The turbine is driven by the power of the sea in both directions. Hmm? What happens in this? The water moves from sea to the tidal basin, turbine is get rotate and we get a power. Same, water from the tidal basin moves towards the sea, turbine is also get rotated and we get a power generation. Let's see the main parts of the tidal power plant. Tidal power plant consists of three main parts. The first being the barrage, known as a dam itself, holding the water back during the high tide. The second part is a sluice gate that let water through the third part. And the third part consists of turbine and a generator, resulting in electricity generation. Let's see the tidal barrage. A tidal barrage is a dam-like structure used to capture the energy from masses of water moving in and out of the bay due to the tidal forces. Then, then instead of damming water on one side like conventional dam, a tidal barrage allows water to flow into a bay during high tide condition and release the water during the low tide condition. This is done by measuring the tidal flow and controlling the sluice gates at key times of the tidal cycle. Turbines are placed at these sluices to capture the energy as the water flows in and out. Next part is a sluice gate. The sluice gates are left open during the high tide and closed during the low tide to create a water level differential, creating potential difference that powers the turbine when water is released. The next part is a tidal stream generator. Tidal stream generators are very similar to wind turbine except they're below the water surface instead of above or on land. The turbine and generator converts the movement of water coming from change in tide, the kinetic energy into the electricity. Water is 830 times denser than air and therefore can generate electricity at lower speeds than wind turbine. Next moves towards the operation method of utilization of tidal energy. A number of concepts have been proposed for generating electricity by utilizing the head that can be developed by rise and fall of tides to operate hydraulic turbine. This power generation from tides involves flow between artificially developed basins. These are having two types. First one is a single basin arrangement and second one is a double basin arrangement. Let's see the first one, single basin arrangement. In this scheme has one barrage and one water storage basin. One way system, the incoming tide is allowed to fill the basin through sluice ways during the tide and impounded water is used to generate electricity by letting the water flow from basin to the sea through the turbine during single basin scheme is intermittent generation of a power. Then double basin arrangement. In double basin scheme, there are two basins on the landward side with powerhouses located at the interconnecting waterway between the two basins. Here, turbine is located in between the interconnecting of two basins. Hmm? Let's see the tidal energy potential in India. Hmm? Region, state, and tidal potential in megawatt. The Gulf of Cambay placed at Khambat in Gujarat state. It having 7,000 megawatt capacity. Then Gulf of Kutch. This is also placed in Gujarat, which having 12,000 megawatt capacity. And the last one is the Gangetic Delta, Sundarban, placed in West Bengal, which having only 100 tidal potential megawatt capacity. Let's move towards the advantages of tidal energy. It is an inexhaustible source of energy. Tidal energy is the environmental friendly energy and doesn't produce greenhouse gases. As 71% of Earth's surface is covered by water, there is a scope to generate this energy on large scale. Then the efficiency of tidal power is a far greater as compared to coal, solar or wind energy. Its efficiency is around 80%. Tidal energy doesn't require any kind of fuel to run. The life of tidal energy power plant is very long. The large density of water, almost 1000 times greater than in air, results in a very large amount of energy to get out of the tidal currents even if the speed is low. Let's see the disadvantages of tidal energy. First one, cost of construction of tidal power plant is high. There are very few few ideal locations for construction of plant, and they too are localized to coastal regions only. Then the intensity of sea waves is unpredictable and there can be damage to power generation of units. Then the influence aquatic life, which adversely can disrupt migration of fish. The actual generation is for short period of a time. The tides only happen twice a day, so electricity can be produced only for that time. Then usually the places where tidal energy is produced are far away from the place where it is consumed. This transmission is expensive and difficult. Okay, these are the references. Thank you.